Good afternoon, good evening, welcome. Thanks for coming. So, mbed is ARM's IoT. Sorry, somebody's just stealing a case of beer. That's fine. mbed, it's ARM's IoT platform. If you don't know what IoT is, it's Internet of Things. What does that mean? It is effectively connected devices. That can be anything from watch, fridge, TV, sensors, door locks that you can manage with your phone, all those sort of things. So just to give you an overview of mbed, mbed itself was announced last year in around October, November time, 2014, at ARM's TechCon. It's the new incarnation is a complete platform, whereas before it was just literally the operating system that ran on one of these little boards that has multiple sensors on it. The platform is split into two: mbed OS, which is what runs on the M-class device, and mbed device server, which, as its name says, is a server, and it helps manage those smaller devices that are out there. And the reason behind it is to help accelerate time to market for customers. And we've got a lot of partnerships out there with silicon providers, cloud providers. IBM has announced a partnership with ARM mbed to provide cloud services. And how we do this is by providing the blocks for people to then build their end solution. So we're effectively the Lego pieces for Internet of Things. So there's plenty of momentum going on. ARM purchased a company about 2 years ago called Sensinode. They've been around now for 8 years. They already are out in commercial use as it stands now. And the new mbed platform is a combination of ARM's in-house mbed married with Sensinode. There are well over 9,000 projects based on mbed now. Some of them are commercial, some of them are hobbyist. There's a huge variety of things being used. There are well over 30 boards now. This one's by Nordic, Freescale, NXP, are just some of the other vendors. And that ecosystem is growing constantly. As I mentioned, mbed platform split into two. You've got the device server on top, which has both free to use and commercial versions. It does a lot of the application and device management, and it helps, as I said, grow customers' user base. mbed OS that runs on the actual device, and one thing to note is mbed is designed for M-class processors, so not the Cortex-A class, things that you get in your mobile phone or tablet or even Raspberry Pi. It is much smaller, much lighter weight. Most boards have a variety of sensors in there. And around covering both components, there's the mbed ecosystem made up of developers, commercial partners, services, companies. So that's great, but in this context, at an event like this, what's in it for developers? Why would you want to care about it? There's actually quite a bit for developers within mbed. You've got productivity use cases, security, leveraging expertise on the Linux stack within the security field, within networking aspect of things. Management is a big opportunity for people to work in. And then there's the optimizations for efficiency and such like. As mentioned, there's well over 30 development boards available for people to use. mbed is designed from the ground up to be cross-platform. So you can change, you can prototype on a NXP board and then decide, actually, in production, I'm going to use a Nordic board, and it will work. Your code is completely transportable. And as I mentioned, most of these boards have a multitude of sensors and solutions. A lot of them have Wi-Fi, Bluetooth, and especially Bluetooth LE, so low energy. There's cell modems. 6LoWPAN for network connectivity, and Thread. There's well over 70,000 members of the mbed community as it stands now, and there's a lot of knowledge sharing within forums and such like, and helping those new to the ecosystem get up and running. To get up and running, there are a whole heap of different resources available to you. There's documentation and such like. So there's the homepage at mbed.org, and there's the developer portal at developer.mbed, and there's a YouTube channel with lots of instructional videos, guides, how-tos, etc. Cookbook is a great resource for prototyping and ensuring that your code valid, and the forum for asking help. So not only is mbed OS multi-platform from the actual device, you can actually code from a variety of platforms, whether it be offline on your desktop, regardless of OS, or if you want, you can do it directly in the browser. The mbed compiler has got a web-hosted instance. So with a lot of IoT devices, they generate lots of little bits of data, whether it be temperature sensing, moisture sensing, movement, etc. All that stuff gets pushed up, and that multitude of little bits of data creates a lot of big data analytics. Ensuring that you get all that data together is quite key. There's a lot of effort in ensuring that all that data traveling from the devices up to the device server is encrypted. The management is all seamless. So part of mbed is ensuring that we use standards and driving standards with protocols right the way through the stack. So you've got standard TCP/IP, IPv4, v6, and 6LoWPAN. 6LoWPAN is effectively creating a low-powered IPv6 enabled network locally rather than having to rely on the internet. Utilizing things like TCP, UDP, the protocols, TLS for encryption, standard HTTPS, there's REST APIs, there's JSON for ensuring that all the encapsulation's there. So, how many people here have heard of Thread? Wunderbar. Excellent. So,
that's the thing that sew things together, right?
That is a thread, yes. Not quite the exact interpretation I was looking for, but sure, let's go with that. So it's collaboratively been designed. It's a standard with a lot of input from big names like Nest, Freescale, Samsung, etc. And so you've got a thread access point on the available in the gateway. The thread communication is all low power, so these devices quite often will be running off a battery or of some form, so they will not be necessarily plugged into the mains, pulling a lot of power. There's a huge range of devices that are able to be deployed and grow the network within that. Thread is utilizes mesh networking, so the more devices you have, the stronger your network connectivity and the wider reach. And it takes IP all the way up to the edge of that mesh network. So it's using standard protocols that you're already familiar with. And with that, there is a mature and well-developed security model to ensure that the traffic is well encrypted. So on the actual device server, it's easy integration. There's support for the connectivity of all the devices, manage the security of all your devices, running on the standards as I mentioned, and the management of the device server is designed from the ground up to be lightweight. So as an example of IoT in wide-scale commercial use, there are multiple cities that have deployed IoT devices with mbed. This is one of the examples that is active in the wild. So each street light has an mbed style device on top of it. In it are sensors for light. So you set your parameter of if sunlight gets to X variable, power on the light. Because all the devices use a mesh networking, so with each street light, they connect to the one before it. There's the strength of your network there. It's all encrypted traffic. All that data goes to a gateway that's connected to the WAN in one form or another. Generally speaking, they are powered by Linux, standard Linux OS. And invariably they'll be running on Cortex-A class processors. From the gateway, the data is then sent up to the device server where the utility admins can monitor how often the lights are coming on. They can monitor which lights have a broken bulb, so they know when to send the maintenance guys out to fix it. They can monitor voltage, power spikes, etc. They get all the information from the mbed device sitting on those lampposts, and they're able to analyze and budget accordingly. So that's a commercial use case, some hobbyist style use cases if you wish. Robot, all sensors, so it's able to autonomously move around, completely powered by open source, both running on the ground and within water, hooking up to a webcam for motion detection. There's multiple instantiations of a home weather center in your garden or wherever. There's quite a few use cases of gardening applications. So monitoring pH level of the soil, moisture in the soil, sunlight, temperature, etc. So you know when you need to go and water the plants. You can hook up automatic irrigation system so that when moisture level gets below a certain point, it automatically triggers the irrigation. So basic wearable example here, the low-powered device connects via Bluetooth, much in the same way that my Android Wear device does now, to either a cell phone or a other internet gateway, something that can talk to the cloud. And you can set it to do your multiple monitoring, whether it be for health, movement, your step tracking, etc. Smart home can again be utilized in much the same way. You can have a device in whichever shape you wish in the house. Again, utilizing all the sensors that you have on board the M-Class board there to monitor your temperature, air, purity, and such like. And then you can have an application, whether it be a web app, mobile app, etc., and you can monitor and control things from there. Hook it up to a Nest thermostat for your automatic temperature adjustments. So, as I said, mbed has a community. It is growing, but we want to ensure that it continues to grow. So, getting involved is super easy. Most people have a common vision for how IoT applications want to go, and there's plenty of opportunities for collaboration. As an example of some of the partners in the cloud, I mentioned IBM already. There's KDDI in Japan, Telefonica in Spain. Salesforce have cloud applications available for mbed. There's multiple ecosystem partners if you need to get components and such like Farnell, Element 14. And then there's the silicon partners with a large variety globally. So what is the part that OpenSUSE and Linux to play within the whole IoT space? So you won't be able to run a standard Linux distribution on one of these devices. They have no MMU. It's just not going to work. Generally speaking, it's RTOS style systems that are running there. So a good way for Linux to get involved in IoT is at the gateway, managing all the data that's going up to the cloud, and ensuring the communications between the device server and the devices works well. Analytics, applications, you know, the end user application, whether it be mobile, web, fat client, etc. Prime opportunity for Linux. There's lots of frameworks available for you to use there. Another area where Linux can leverage its power is as a controller. So you can utilize Linux in association with applications to manage and orchestrate how these devices work. Barmer. Not entirely sure why he's there. Or are you? Correct. Developers, 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 developers. So Linux has a huge, huge pool of developers in lots of different areas. They have the power, the knowledge, the experience of tinkering. They know what they have. Generally speaking, Linux developers have a whole heap of itches that they try and force upon devices and applications that aren't suited really for the job, but it's what they've got to hand, it'll do. Mbed helps to fix those itches, help you scratch them. I know Lars used a Raspberry Pi for a Hack Week project to monitor data center for OpenSUSE, and he had to get a whole heap of different bits for sensors and work out how he's going to communicate, etc. Mbed would have made that project so much easier, and he could have concentrated on his fancy Ruby on Rails skills, etc. that he has. But ultimately, Linux is the perfect partner for Mbed OS, both on the client device and on the device server. It just works well together. A lot of Mbed is Apache 2 licensed. The online compiler is Apache 2 licensed. You can use GCC or a variety of different compilers available for you to utilize there. Sorry? The kittens? Yes, actually it does. I'm a dog man myself. So, how am I doing? I've got a bit of time. Any questions? I'll get back to you in a second. Back to you in a second. Any other questions? Go on.
So,
now it works. Okay, so how is the relation between mbed and the All-Join Alliance? And how are you playing with the Linux Foundation collaboration project for IoT?
Somebody's been paying attention. You're at Collab Summit. It's a good point. So at the moment, mbed is not part of All-Join, All-Seen. It is something that we are tracking, trying to understand better how that's going to play out and understand their target audience. Does it really line up with how we want or how we envision the IoT play going? There's not been any decision at present, as far as I'm aware of, whether we are definitely or not. I do know that we are tracking it, certainly. Many of our partners are in AllJoin. Is there a need for us to be in there as well? Quite possibly, but at the moment it's still to be decided. Next. Actually, just
a quick question to the audience. Is there actually anyone already using mbed here?
Good point, thanks. A little present.
Oh, thank you.
What I was wondering when I saw street lamps, how do you prevent that one device, I mean, I take over one street lamp, how do you prevent me blocking messages from the others and just injecting? And you know, are those new protocols audited already?
So 6LoWPAN has been, as far as I'm aware, and it's been in use for quite some time. Zigbee is another mesh networking protocol that has been around for quite some time. With regards to the first part of the question, I would have to defer to my security colleagues who would much be better placed to answer that. I genuinely couldn't honestly answer it. But thanks for the question. That's right, they're resilient. They are now. Sorry? Mbed device server is, I don't think it is completely open. But you, yeah. I mean, there's, you don't.
Andrew, could you please repeat the question so that everyone understands it?
Yeah, so the question was, is mbed device server open source? I don't believe all of it is. There are certain components. So mbed device server is still in a beta stage. It should be publicly released in November this year, the 1.0 for mbed device server. And more details will be published then. Currently it's in beta with partners, and it goes public beta, I believe, around summertime.
Okay, I wanted to ask, you mentioned that all these devices are connected via some low power wireless link. You mentioned the Bluetooth low power, you mentioned Zigbee. Is it specified somewhere in mbed what is the preferred way of this wireless connection? Do all these devices that you showed that there is plenty of those have some standard way of communicating, or do I need to make sure that devices that I buy are using the same technology to connect to each other?
So the protocol, whether it be Zigbee, 6LoWPAN, etc., that's in the mbed device OS. Not so much on the, if they've got a Wi-Fi chip on them, you'll be able to communicate via 6LoWPAN.
Yeah, and if they don't, for Zigbee, I think that there are, you can use it on different megahertz and yeah, so so it's basically up to the device?
As far as I'm aware, yes.
Okay.
You'll have to come down, Micha. I'm not going to throw it that far.
You mentioned the already existing mesh networks for the lights in the cities. I'm just curious how huge those mesh networks can be, or in reality are currently. Is it like dozens or thousands of those devices, or are there some limits?
It's certainly hundreds. I believe one of the cities has the 5,000 mesh network. I'm not sure if they are all just in the single mesh or if there's multiple mesh networks communicating with, so you have a block of streetlights and they've got their own gateway and each block has its own gateway, etc. of, a few hundred. I'm not sure on the exact implementation on that aspect.
Thank you.
No.
Okay. So I now imagine if I want to use those devices for home automation, I would have to somehow set up a server. So I would have to have a device that runs the mbed server. I would buy a lot of small devices and put them everywhere to just measure some stuff. How do I set that stuff up? How do I actually configure the devices, like to connect them to my Wi-Fi or whatever?
The cookbook is your friend. The mbed cookbook. That will give you the best solution for whether it's internal or external usage and how to actually hook them all up together to the end access point. I wouldn't like to say, and I wouldn't like to pass any advice, because I'm probably not the best person on the implementation aspect of it.
Okay, thank you.
But you can start now.
What is the price range of the devices in general?
Tens of dollars.
So if I wanted to upgrade my house, switching on every light, it would probably cost me a couple of hundreds to thousands.
It depends on the size of your house.
About 80 square meters.
Yeah. Yeah, they're generally around, if you want to make it yourself, it's about 15, I think boards range from about, roughly about $15, if that. You can go to some companies that implement that sort of technology, and you're going to pay about $150 for the bulb. And yeah, and then you then have to log in, create an account on their web service. You're not entirely sure how well they are. So yeah, you're looking, if you've got say 10 rooms, $100 thereabouts, and then it's a matter of a little bit of coding time. There are. So I'm out of mbed boards, but oops, close. Let's try again.
Getting dangerous now.
No, oops. You can keep that one. Sorry. Any other questions?
A follow-up from my side. So mbed, from my view, was primarily like a development and evaluation platform. So on the one hand, when you're talking that the streetlights are using mbed OS, does that mean that they also have like the USB connector so that someone could actually go and reflash them? Or on the other hand, is there like service partners that would then, if you want to have those, a particular solution that you've programmed in a large scale, such as hundreds of light bulbs or whatever, are there partners that would then design a custom PCB for you that might be less expensive than those boards?
Yes. There would certainly be partners that can take your proof of concept on a NXP board or a Nordic board, and then implement the functionality that you're after, and your code can just be transferred across and it all works. With regards to how the devices look like on the example, I haven't seen them myself, so I couldn't say. But generally speaking, it would be through a partner that would do that development aspect to ensure it's as low maintenance as possible. It is also possible to do an over-the-air update to the devices from the mbed server via the gateway.
So can we say in general that code developed for mbed OS can be deployed to any Cortex-M microcontroller, or does it have to be a certain mbed platform?
I wouldn't say it's any M class. It would need to be mbed certified platforms, which is why there's only around 40 tops mbed platforms, yet there are numerous M class powered devices.
The Polar SSL library was recently purchased by ARM and renamed to mbed TLS. I assume that it is because it's becoming part of this development platform. And thus mbed TLS will remain supported on other architectures than ARM?
Yes, it is going to be maintained. The Polar SSL acquisition was done primarily to bolster the security of mbed OS and ensure that there is a proper SSL library available for use. The external usage support should be maintained. I've not heard any word on them dropping any support for other architectures or platforms. Close. Really? Again? Oh, that's time. Sorry. Thank you very much. Okay.
I'm going to ask you anyway.
Go on.
If not, I'll ask you over beer. It's all the
Sure.
same. So why do mbed at all? Why not run the Linux kernel? Strip it down and just put the device drivers into place.
Because the wonderful Wizard of Oz. There are, whilst it's possible to strip kernel down, and I think we'd have to run UC Linux because there's no MMU. It just becomes more of a headache. Having an RTOS was the best fit for the job. The amount of modifications that would have been needed to a standard Linux, the overhead on that from a back office perspective, maintenance and development would have been too high. There was already expertise in the RTOS world that we could easily tap into. It was just a much easier fit to get to market quickly. Maybe.
So, Marcus, this morning I was actually talking about enabling some of those platforms to run Linux, and the issue is that you need about 4 megabyte of RAM to actually run a Linux kernel, plus anything that you actually want to run in user space. And some of those devices, they have 144, 256K of SRAM, and no external SD-RAM or anything. Plus, well, if you're lucky, you have 2 MB of flash storage, usually less.
Yeah, that's what they have today. Text here will have 10 times as much.
Quite possibly.
less.
Yeah, I mean, that's what they may have today, but, you know, in a year from now, they'll have 10 times as much for less than half the price.
But if we wait in a year's time, then we could be too
No,
late
not
to
10
market.
years, 1 year. But yeah, I'm not saying you should wait. It's just, it seems that we're going back to, you know, oh, we need something, the ARM community needs something special. And so we create something special. After the ARM community has spent the last 3 years getting rid of we are so special and putting stuff upstream, now you're starting the whole cycle over again, and it seemed kind of like the definition of insanity in a way.
But we're all special in our own way.
Well, we know about that
So,
with you, and that's okay.
Yeah, I mean, it's... RTOS is, you know, real-time OSs are used quite extensively on the M-class platform, whether it be within automotive, industry, IoT. There are multiple valid use cases for real-time OS versus a standard Linux stack. It may be possible in a year's time to just transport all the embed over to a standard Linux stack. I don't know. I'm not directly involved in any of the embed development, so I couldn't say on how much work that would take. But it is something that has been raised, and the decision was felt that for time to market and getting in there now, it was the sensible fit. We are ensuring that we're as standards compliant as possible, open protocols, open standards, so that, you know, there is the possibility then to migrate platform afterwards.
Are all the tools available in the OBS already?
Sorry?
Are all the tools, like compiler and stuff, available in the OBS?
They're available in OBS. I don't think they are in OBS, but
So
it's online. There's an online compiler.
I did package the PyOCD package, and so far I don't have an mbed device, so I would be very interested in feedback. That's also why I asked initially who of you is already using mbed. So those of you who got aboard, please try out the Python 3-PyOCD or Python-PyOCD package and report whether it works. If not, file bug reports or updates and so on to improve that. And also, as I mentioned this morning, you can use our GCC from the ARMv7 repository, ARMv7 repository, to build code for Cortex-M devices. The only exception is that we don't have multi-lib libgcc. That means either you need to have the particular code that you're running needs to have certain, you know, assembler files implementing certain intrinsic functions from GCC, or you need to build that library some way. But binutils definitely is able to do that.
Almost. That's
Any
it.
further questions?
Thank you very much.
If not, I do have one myself. So, beyond mbed even, you know, the IoT seems to be propagating this idea that all devices need to communicate wirelessly with each other. And obviously ARM's interest is getting royalties from the processors sold, but if those processors really grow as ARM predicts, doesn't that cause a huge jam in the ISM band? I mean, like, are all these new protocols that are being developed in the same range of frequencies really compatible and running alongside each other?
Possibly. But I think there's enough spectrum to be able to allow it for the short to mid-term.
You mentioned Zentek as one of their partners, and they're trying to push this long-range technology, which is using a different frequency from the others, and saying that it's less affected by noise and what so on, and that you can have distances up to 3 kilometers covered. But once people actually start adopting that, I somewhat doubt that that will remain the case.
Possibly not. Possibly. So, thank you very much.